This is Activity 3, a puzzling puzzle from Lesson 5, solving any linear equation. And so this is an algebra puzzle. And it says that Tyler has invented a number puzzle. Claire picks a number, goes through these steps, and then at the end, Tyler says, and Claire says what her answer is at the end, -3, and then Tyler says, oh, the original number that you chose must have been 3. And the question is, how did Tyler figure that out? And there are a bunch of these puzzles online. So if you do an online search for actually number puzzle, I think would work as well. But if you use cool math algebra tricks, that works. If you use algebra cadabra, that one works. You come up with many of these puzzles to puzzle through. And as you puzzle through something, you're looking for what's the trick. So how do you do this puzzle? What's the trick to do it? And as you do that, you reach the level of understanding. Oh, gee, I get it now. This is the trick to doing this. And these algebra puzzles, basically the trick is always the same. You work through the algebra. You simplify the expression. So if I wrote each of these steps out, so this is take a number and triple it. So x is going to be the number that I chose in the beginning, or that Claire chooses in the beginning. So take a number, think of a number, and then triple that number. Then subtract 7 from that. Then take that difference, I guess, that operation, and double that result. So multiply the result by 2. Then subtract 22. And then divide everything by 6. Well, if you do that, you're going to see what the trick is. Rather than go through all these steps, one simple step is 2. And so let's go through the simplifying the expression. So 2 times 3x minus 7 is the same as 2 times 3x minus 14. So this 2 times 3x and this 2 times 7. And that's still subtract 22 from that. Then you do all of these, you combine all of these terms into 6x. So 2 times 3x is 6x plus a -14. So I'm going to change this to adding a -14 and adding a -22. Once you do that, you can divide everything by 6. But you still have to combine this -14 and -22. That's -36. Now there's a couple ways to do this one. You can divide each term by 6, so 6x divided by 6, and -36 divided by 6, or you can factor out the 6, which is actually dividing by 6. So 6x divided by 6 leaves you with 1x, so 6 divided by 6 is 1, and a -36 divided by 6 is -6. So this becomes 6 times x plus a -6. You divide all that by 6. Well, these 6's cancel out. 6 divided by 6 is 1, and you're left with x plus a -6. X plus -6. Let me just go back to here just for a second. Remember, when you add fractions, you add fractions with the same denominator, like denominators. So you could split this out to be 6x divided by 6 plus a -36 divided by 6. And then work with each one of those individually, and you're going to get x plus a -6. So you get down to here, x is the number that Claire initially chose. So y is equal to the answer. So you take the number she initially chose and you add -6. That's how so the number she originally chose was 3. You add -6 to 3, and you end up at -3. So instead of going through all these steps, you could just add -6. Now this gets a little bit confusing. You have to keep track of what's the answer to the puzzle, which is y. Y equals x plus -6. And what's the number that was selected in the beginning, that was chosen in the beginning? That's x. And so if you look at this, now I want to know what the number chosen in the beginning was. What's x equal to? Well, x is equal to y, the answer, plus a +6. So you can add a +6 to this side, add +6 to this side. So x is equal to y plus +6. And I just rewrote it in this direction. X is equal to y plus +6. So a way to say that in words, so here's the y is -3, so y is the answer. then you just add 6 to that negative 3, and you get the number that was chosen. So if you look at this, you start to realize that the answer is 6 less than the number chosen. So x is the number chosen, 3, y, which is negative 3, is 6 less than the number chosen. So the answer is 6 less than the number chosen. So if y is the number that is the answer, then the number chosen is 6 more than that. So that means that you have to take the answer and add 6 to that, because the answer is 6 less than the number chosen. So that means that the number chosen is 6 more than the answer. This gets confusing. I'm going to draw a little picture of this in a little while, but the puzzle answer is 6 less than the number chosen. So the puzzle answer is 6 less than the number chosen. That means I have to take the answer and add 6 to that, because this answer is 6 less than this x. So add 6 to the puzzle answer. And again, I'm going to make a little drawing of this on a number line in a few moments. This language is confusing. You have to really keep track of what you're saying. So the way to do this is to try another problem. So what if the answer is negative 2? What was the number chosen? Well, if you start with, if you get an answer of negative 2, that means that you started with a number that is 6 more than the answer. The answer is 6 less than the number chosen. That means that the number you started with is 6 more than your answer. So you have to add 6 to the answer. So the way to do this in the end is just to keep track of whatever the person that you're playing this game with, whatever they say is their answer, you have to add 6 to that. So negative 2 plus a positive 6 equals 4. So if we try that, we can work back. One way to figure this out is just to work backwards. Rather than simplify the expression, begin with the number that is the answer and work backwards, and you'll get the number that was started with. So if I take, this is the simplified expression. Now if I work backwards, this is going from triple a number, so triple a number, subtract 7, and so on to get to this expression. But now if I work backwards, so I'm going to first multiply by 6. So instead of divide by 6, I'm going to multiply by 6. Instead of subtract 22, I'm going to add 22. So I'm working in the opposite direction. I'm working backwards. So I'm starting with negative 2, multiplying by 6, adding 22, dividing by 2, adding 7, and dividing by 3, and I get 4. So you take the answer and you add 6 to that, and that gets you to 4. So I'm going to work with this in more detail because this is confusing stuff, and one of the reasons it's a puzzle is it's hard to keep track of the language, and you have to practice. So a picture of this is the puzzle answer is 6 less than the number chosen. So this is the answer. That's 6 less than the number chosen. So take the number chosen, add negative 6 to it, you're going to get to the answer. Take the answer and add, I hope I said add a negative 6 to it. Take the answer and add a positive 6, and you're going to get back to the number that was chosen. So take the number chosen and add negative 6, you're going to get the answer. Then take the answer, that's going to get you back, and add positive 6, that's going to get you back to the number chosen. So this is working backwards. This is figuring out how to do it in one step. All right, so what if we take a look at all of these steps and change everything to multiplication? Oh, actually, the first thing I did here is here are all the steps, and then what I did is I just labeled the steps going backwards. So this is all using the inverse operation, but the numbers all stay the same. So you divide by 6 to go backwards, you're going to multiply by 6. To subtract 22 to go backwards, you're going to add 22. To double the result, to go backwards, you're going to divide by 2. Because double means to multiply by 2. To subtract 7, you're going to add 7. And to triple a number, which means multiply by 3, you're going to divide by 3. So you're going to work backwards by using the inverse operation, but notice that all the numbers stay the same. Now, I have said over and over and over again that I want to change all subtraction to adding the additive inverse. And it's the same with division. Division actually doesn't show up very much, but I would change all the division to multiplying by the multiplicative inverse. So the first thing I want to do is change all of these steps to either addition or multiplication. So either add or multiply. So instead of triple a number, actually not instead of, but triple a number is the same as multiply by 3. Here it subtracts 7, so that's the same as adding the additive inverse, negative 7. Double the result, that's the same as multiply by 2. Subtract 22, that's the same as adding negative 22. And divide by 6, that's the same as multiplying by 1/6, the multiplicative inverse. Now, the reason I'm doing this is to go through using the language. And what I'm going to suggest in the end is that take some of these number puzzles, change everything to subtraction and division, and try to do it. Then change everything to multiplication and addition, and try to do it. And then mix the operations up and see what you get. So use this language to work through a level of understanding of the algebra. So now, if I work backwards, notice what happens. So now I'm going to work backwards. Over here, when we work backwards, we used the same numbers. Numbers remain the same, but we use the inverse operation. Now, if we're using addition or multiplication for the puzzle, if we work backwards, the operations don't change. Still multiply, add, multiply, add, multiply. But what changes is the number. You're either going to use the additive or the multiplicative inverse. So multiply by 1/6, the working backwards, the inverse of that is to multiply by 6, the multiplicative inverse. To add a negative 22, the inverse of that is to add a positive 22. To multiply by 2, the inverse of that is to multiply by 1/2. To add negative 7, the inverse of that is to add a positive 7, and the multiply by 3, the inverse of that is to multiply by 1/3. So again, it's the use of the language. That's what you're going to practice as you go through this. So to work backwards, to reverse each step, use the additive or multiplicative inverse. Over here, we kept the numbers the same, and we used the inverse operation. So you're starting to understand what the difference between those two approaches is. All right, so I went through this already. I did change this to adding a negative 7. So over here, let's see, a triple number, add negative 7, add negative 7. Multiply by 2, add negative 22, add negative 22, and multiply by 1/6. So I changed divide by 6 to multiply by 1/6. You simplify all this, and you get this same expression, x plus a negative 6. So the answer is x plus a negative 6. To get this beginning problem, the number you selected, you take the answer and you add 6 to that. All right, so to work backwards, we're going to use the same operation each time, but we're going to use either the additive or the multiplicative inverse. So this is 6y. So multiply by 6. It was, at the end, it was multiplied by 1/6, but now we're working backwards. So multiply by 6. Add a positive 22. Add positive 22. Multiply by 1/2. Multiply all of this by 1/2. Add a positive 7. Add a positive 7. And then multiply by 1/3. So multiply everything by 1/3. You simplify all this, and you get the inverse of this expression right here. So x, the number selected, is equal to the answer plus a positive 6. X, the number selected right here, is the answer plus a positive 6. You move this negative 6 over here, it becomes a positive 6. And again, this number line, this visual, if you begin with x, to get the answer, you add a -6. To begin with x, to get this answer, you add a -6. So x goes to y this way. But if you're given the answer, I got a -2, to get back to the number selected, you add a +6. That gets you back to +4. So there's a lot going on. I would suggest to go to the internet, get some more of these puzzles, try to do everything, as I said before, as multiplication and addition, and then try to do the reverse. Try to do every step as division and subtraction. You can do that because they are inverse operations. And then mix things up, try to move everything over to two of the operations or their inverse operations. Just play around with it. And you have to go through using this language to really truly understand the algebra.